Okay, hello Math Counts friends. Today, I thought it would be a good idea since our school competition is coming up to go through a school sprint round test. And so let me start by just pointing you to the test that we're going to be looking at. So if you go to the Google Drive and you go into sprint round, you should be able to search down until you get to the 2002 school sprint round. And if you double click on that, that should give you the test and you should be able to just print it out. And I would encourage you to stop the video right now, go print this out, and give yourself a 40-minute timer and try to answer as many problems as you can in 40 minutes. And then score yourself. You can look up the answers also in the Google Drive. So if you go back up to downloads, and then you go to, instead of sprint round, you go to answers, and then you can go and find the 2002 school answers right here. So first, print it out, give yourself 40 minutes, try to answer as many problems as you can in the 40 minutes, then score yourself based on the answers, and then come back and watch the rest of the video. So please pause the video right now and go take care of that before you watch the rest. Okay, so now I assume that you've gone and you've done the test. I hope it worked out well for you. And what I'd like you to do, if you want, you can also pause the video one more time and go try to work out the problems that you didn't get right, even though you're no longer being timed, but just to see if you knew how to do them, if you can figure them out on your own, and then you can come back here and watch the rest of this video. Okay, so now let's go ahead and jump into the problems. I'm going to go through them. If you want, when I get to a problem, you're welcome to pause again and try to work it out if you didn't already do the test. But here is what we have. This is the first problem. So what does it say? It says calculate 1/2 minus 1/4 plus 1/8 minus 1/16. Now, you can choose what order you do this in. So for example, you could do 1/2 minus 1/4, and then you could add an eighth, and then you could subtract a 16th. That's usually what we do. We usually go left to right when we have a bunch of addition and subtraction. But if you're careful about it, you can actually save yourself a little bit of work by doing this, grouping these together, and since and this should give you the same result because we're not changing the order of any subtractions or anything. So here, this one will be a quarter, this one will be a 16th, and then we're just adding those two together. So it's 4/16 plus 1/16, and that's going to give you 5/16. Okay. So let's go ahead and move on to the next one. This one says Midtown Taxi charges $1.60 plus 25 cents per eighth mile. The distance from the hotel to the airport is 16.25 miles. 2 passengers will evenly split the fare. How many dollars will each passenger pay? Express your answer to the nearest hundredth. Okay, so they're asking how many dollars, and they want you to give it to the nearest hundredth. It's important to just watch for what they're asking for so that you give it in the right form. All right, let's take a look at this. So we've got $1.60 that they have to pay just for getting in the taxi, and then they have to pay 25 cents per eighth mile. So what is that going to be for a whole mile? Well, it's $0.25 times 8. That's going to be $2. So $2 a mile basically, and 16 miles would be $32, right? But then there's another quarter mile. That's another 50 cents. So it's $32.50 just for the miles, right? So we can add those together. All right, that'll give us $34.10. And then you have to split it in half because there's 2 passengers. And so if you split that in half, you'll get $17 from the 34 and then 5 cents from the 10 cents being split in half. So that's your final answer. And you would write it as 17.05 because they ask for the number of dollars. All right, next one is calculate just this simple problem here. One thing that might help here is to realize where you can cancel things out. So you might look at all the 7s and see if some of those cancel out. So for example, this is a -7, and this one is a +7 because it's subtracting a -7. So those two will just cancel out. And then this one's a negative 7. And then this one is a positive 7 because you're adding this thing in parentheses, and in here it's adding. So this negative 7 and this positive 7 should cancel out. All the 7s are gone. Now we have positive 4 and a positive 4, and then another positive 4, and then a negative 4. So we can cancel out these two, and we just have 2 4s, which is 8. All right. Let's take a look up here. Here it says Anjali has 230 quarters, 300 dimes, 165 nickels, and Nikki has 210 quarters, 316 dimes, and 173 nickels. How many more cents does Anjali have than Nikki? So you could compute the number of cents that each one has and then subtract, but that would be kind of a lot of work. And it might be easier to just keep track of what is the difference for each one. So for example, if we just look at the quarters first, Anjali has more quarters, right? She has 20 more quarters. So let's give it a plus 20 quarters. We'll just do plus 20 times 25 cents, right? And then if you look at dimes, Anjali has 300 dimes compared to Nikki's 316. So she's down on dimes. So negative 16 times 10. And then in terms of nickels, she's also behind on nickels. She's behind on nickels by 8. So we do a minus 8 times 5. So this one's going to be a minus 40. This one's going to be a minus 160. So altogether, that's minus 200, which is $2 because I'm counting pennies here. And then 20 times 25 is positive. Let's see, if it was 4 times 25, that would be $1, but we got 5 times that much. So this is $5, so 500 pennies. So 500 minus 200 is 300. That's the total number of, that's the number of cents that Anjali has more than Nikki. So it's important here to write this as 300 because it's 300 cents. They're asking for how many cents. If you put 3.00, you might think, oh, that's $3. That's this. Whoop.
Turn off your lights and your audio books now and go to sleep.
Okay.
And I mean it.
My kids have to go to sleep now. Thanks, Alexa.
Turn off your lights and your audio books now and go to sleep. And I mean it.
All right. So you might think, hey, $3 is the same thing as 300 cents. But it doesn't matter because they asked for how many cents. So you have to write it as 300. If you put 3.00, that would be 3.00 cents, which is not the right answer. All right, the next one says, a space shuttle travels from Earth toward the moon at a speed of 30,000 kilometers per hour for 12 hours. The total distance to the moon is 400,000 kilometers, okay? And at the current velocity, how many additional minutes are needed to reach the moon? So first of all, how many kilometers have they gone? Well, it's 30,000 times 12, right? So that'd be 360,000. That's the number of kilometers they've gone. The rocket has gone. And so it needs to go 400,000. So there's 40,000 kilometers left to go, right? 40,000 kilometers left. And the speed is 30,000 kilometers per hour. So the number of hours that is remaining would be 40,000 divided by 30,000. And then they wanted to know, that's the number of hours, but they wanted to know how many additional minutes, not hours. So we got to multiply that by 60. Okay, so this 40,000 over 30,000 is going to be 4/3. So we have 4/3 times 60, and we can cancel this. It's going to be 20. So 4 times 20 is 80. So the answer there is 80. All right. Next one says a whole number n is chosen so that n over 3 is strictly between... Uh-oh. Somebody's calling me. I'm going to pause. Sorry about that. I had a phone call. Let's see. We were on number 6 here. A whole number n is chosen so that n over 3 is strictly between 7.5, 7.5, and 8. What is the value of n? Okay, so strictly between means that it can't be 7.5 and it can't be 8. It has to be somewhere in between, not equal to. So we could write that as an inequality. 7.5 is less than n over 3, which is, oops, I'm running out of room there, which is less than 8. And if we multiply that all by 3, we would have n over 3 less than 24. So since there's only one whole number that works, we're just going to pick the next number less than 24, so which is 23. 23. And if you do 23 over 3, you'll get 7 2/3, which is in between here. If you do anything less than that, like 22, for example, you'd be less than 7.5. And if you go up by 1, you get to 24, which would put it equal to 8, which is not something we want. Okay, so there we go. Let's go ahead and move on to page 2. This one says, Morgan has 3 hockey shirts, 2 football shirts, and 7 baseball shirts in her closet. If she randomly selects one of these shirts, what is the probability that it will not be a baseball shirt? Okay, so you just count up the number of shirts all together. And there's 12 shirts, right? And how many of them are not baseball shirts? Well, 7 of them are baseball shirts, so that means 5 of the 12 are not baseball shirts. So our answer is just 5 out of 12. All right. Okay, it asks for what is the value of x here. You can do a half minus a third. That's going to give you a sixth. So a sixth is equal to 3 over x. And if you want, you can just cross multiply, or you can multiply by 6x if you want. But either way, you're going to get x is equal to 18. So the answer is 18. Okay, the next one says, what is the greatest possible number of digits in a product of a 4-digit number and a 3-digit whole number? So the biggest possible number is going to be 9999 times 999. But multiplying this out, just to find out how many digits it has, is overkill. What you really want to do is you want to say, okay, well, it's going to be a little bit less than 10,000 times 1,000, right? Which is just 10 million. And 10 million has 10 million has 8 digits, but it's the lowest number that has 8 digits, as lowest whole number. And so when we do something smaller, like this problem, so if this thing has 8 digits, this thing is going to have 7 digits, because this is the lowest possible number that has 8 digits. So this thing is only going to have 7 digits. So 7 is the answer there. Okay, the next one is about buying cereal. So the price of a 12-ounce box of cereal is here, and an 18-ounce box of the same cereal sells for this amount. The question is, how many cents per ounce are saved by buying the larger box? So one way you could do this is say, well, if I wanted to get the same amount of cereal as the larger box, I would have to buy like 1.5 of these smaller boxes, right? Because 18 ounces is 1.5 times the size of the 12-ounce box. This is 2 6s and this is 3 6s. So if I took my $2.88, which is the price of one small box, and like a half of a small box would be $1.44. So if I add those together, I'm going to get $4.32, I believe. And so that's how much I would have to pay if I was buying small boxes for the same amount of cereal as I get for $3.78. So how much do I save over that 18-ounce box by doing the $4.32 instead of $3.78? Well, I just have to subtract, right? So $4.32 subtract $3.78, and that's not too hard. I guess that gives us 54 cents. So we have 54 cents that we saved altogether. And we have to divide that by 18 because there were 18 ounces. This is the total amount we saved is 54 cents. But they wanted to know how much we saved per ounce. There were 18 ounces, so we have to divide by 18. And let's see, 54 is 6 times 9, and 18 is 2 times 9. So we can cancel the 9s, and this just becomes 3. So the answer is 3. And they did ask for the number of cents. So you don't want to write 0.03. That would be less than 1 cent, right? They're asking how many cents, so the answer is just 3. All right, let's see. The next problem, they're asking us to simplify this thing with a bunch of fractions in it. If you're adding fractions up on the top here, you're going to have to find a common denominator. So let's see, 12 would work for a common denominator. So you've got 6/12 plus 4/12 plus 3/12. So that's all over 12. That's the numerator. That's this part up here. And then what about the denominator? So the denominator, the common denominator here, between 3, 4, and 5, I think we're going to have to go with 60. So we've got 20. A third is 20 60ths. And then a fourth would be 15 60ths. And then a fifth would be, 12, right? Because 5 feet is 60 inches. So yeah. And then we divide that by 60. So this part here is the numerator. This part here is the denominator. We're dividing these things. So let's simplify it a little bit. This numerator is 6 plus 4 plus 3 is 13 over 12. And then we're dividing by, what is this? This would be 20, 35, 47, 47. Dividing by 47 over 60. Okay, so dividing fractions is like multiplying by the reciprocal, so we have 13 times 60 on the top, and we have 12 times 47 on the bottom. So let's see, the 60 and the 12, that can become 5, and then we just have 13 times 5 is 65 over 47. 65 over 47, and there's no common factors there. We've got it simplified as much as we can. Okay, this one says a cube has a volume of 343 cubic centimeters. What is the number of square centimeters in the surface area of the cube? Okay, now, if you are a good math count student, you would memorize all the squares, 1 squared, 2 squared, 3 squared, all the way up to probably 20 squared. And you'd also memorize all the cubes, 1 cubed, 2 cubed, 3 cubed, all the way up to 10 cubed, which is 1,000. If you do that, you would recognize this number, 343, as being 7 cubed. If you don't have that memorized, you might just try a few numbers, right? So you might know that 5 cubed, for example, is 125. That's kind of an easy one. And 10 cubed is 1,000. So you know it's got to be between 5 and 10, and you might just try to figure out what 6 or 7 cubed is. One thing you can do is just think about what the last digit would be. Like 7 squared has a last digit of 9, and then if you multiply by 7, that's going to have a last digit of 3. So you don't have to figure out the whole thing if you think that's probably going to be an integer. But anyway, this cube has got a side length of 7, and they want to know the surface area. So there are 6 faces of the cube, right? 1, 2, 3 that we can see here, and then there's 3 on the back. And each one of those faces is going to be 7 squared for its area, right? So if we do 7 squared, we'll get the area of one of the faces, and then we have to multiply by the number of faces, which is 6. So let's see, if we multiply that out, 49 times 6, we're going to get 294. Okay, we've done 2 pages. Let's go ahead and start the next one. What is the greatest 3-digit multiple of 33 that can be written using 3 different digits? Okay. So first of all, what is the greatest 3-digit multiple of 33 that there is? Well, you want to get up close to 1,000, right? One way is you could go all the way up to 990. 990 is going to be a multiple of 33 because 99 is 33 times 3, and then you multiply by another 10. So this is really times 30. Will get you from 33 up to 990, and that is the biggest 3-digit multiple of 33, right? Because if you add another 33 to this, you'll be over 1,000. But that's not the question. They want to know what the greatest 3-digit multiple of 33 that can be written using 3 different digits. And since this one has 2 9s in it, this one doesn't count. So what you can do is just subtract 33 until you get something with all 3 digits being different. And actually, you only have to do that once. As soon as you subtract, you get 957. And that's all different digits. So that can be our answer right there. Okay, John divided his souvenir hat pins into 2 piles. The 2 piles had an equal number of pins. He gave his brother a half of a third of 1 pile. So that's a half of a third of means multiply of 1 pile. And 1 pile was already only a half of his pins because they were evenly divided. So it's a half of a third of a half of all his pins. And it says John had 66 pins left. How many pins did John originally have? So first, let's figure out what fraction he gave away. It's just multiplying this all together. That's going to give us what? 1/12. So he gave away 1/12. So if he started out with all his pins and he gave away 1/12 of them, how much is left? Well, 11/12 of them are left. And the 11/12 of his original number is equal to 66. Right? Okay, so now we can solve for x by multiplying by 12 over 11. So we will get x equals 66 times 12 over 11. And 66 over 11, fortunately, just cancels out really nicely to just give us 6. So x is just 6 times 12, which is 72. All right, let's go on to the next one. The sum of the squares of two positive integers is 193. The product of the two integers is 84. What is the sum of the two integers? So this is a tricky one. You could do this by guessing a few different things and checking. Because they're integers, there's sort of a limited number of possibilities. But there is a trick here, and I'm going to show you the trick. If you have x plus y and you square it, you can do FOIL on this to figure out that this is, or you could probably just have this memorized, that this is x squared plus 2xy plus y squared. Or I can write that also as x squared plus y squared, this is the sum of the squares, plus 2xy. Okay, so we know the sum of the squares is 193. So this thing here is 193. We also know the product of the two integers is 84. So this thing here is 84. And what we want to know is the sum of the two integers, which is over here, except that this is the sum of the integers squared. So we could take the square root of both sides here, and we get the thing we're looking for is going to be the square root of 193, that was this part here, plus 2 times 84. Okay, so this is going to be the sum of the sum of the squares, because if you square it, you get what's here. Okay, so then you just have to plug it in and see what you get. So if you multiply this, and add it in here, you get the square root of 361. And if you have your square roots memorized up to 20, you'll recognize that as 19 squared. Square root of 19 squared is just 19. Okay, working 22 hours in the second week of June, Xenia was able to earn $47.60 more than during the first week of June when she worked 15 hours. If her hourly wage was constant, how many dollars did she earn during the first 2 weeks of June? Express your answer to the nearest hundredth. Okay, so this is how much more she earned by working 22 hours than when she worked 15 hours. So that must be 7 times her hourly wage. So we can do 7 divided into $47.60. This is going to be 6 here. It's going to give us 42. We're just doing long division now. This is going to be 5. And then, well, we have a 6 here. Put the decimal point here. So 7 goes into 56. Let's see. That would be, what, 8 times, right? 6.8. And then that exactly cancels out. So it's $6.80. Is her hourly wage. So that's her wage per hour. What do they want to know? Hourly wage is constant. How many dollars did she earn during the first 2 weeks of June? So what was the total number of hours she worked during the first 2 weeks of June? 1 week she worked 22 hours. That was the second week. And the first week she worked 15 hours. So altogether it's 37 hours. So it's 680 times 37, and yeah, I guess you just have to multiply that out, and if you do that, you'll get 251. You don't get a calculator, so you have to do this the old-fashioned way. $251.60. They say express your answer to the nearest hundredth. So this is the answer here. 251.60. That's the number of dollars that she earned during the first 2 weeks. All right. Okay, let's. You know what? There might be actually an easier way than doing this multiplication. Like, for example, you could figure out how much she made in the first week by just multiplying by 15. And it might be a little easier to multiply 680 by 15. And if you do that, you get the amount that she earned in the first week, which is $102. And then you can just say, okay, well, the other week she earned $47.60 more than that. So she earned another 102, but she also earned $47.60. So if you can add these three numbers up and you get to 251.60. That's another way to do it. All right, number 17 says, of the eggs produced by salmon, 80% hatch, and of those, 25% survive to migrate to the ocean. Okay, so think about this. Like, let's say you had 100 eggs, 80 of them would hatch, and then a quarter of those, which is 20, would migrate to the ocean. So really, you need 5 eggs to get 1 to the ocean. So it says how many eggs are needed to produce 100 salmon that migrate to the ocean. Okay, so to get 100, you need 500, right? So this is 500. And you can check your answer by saying 80% of this, right? So that would be 400, and then 25% of that would be 100. Okay, Julian has 800 identical 1 centimeter by 1 centimeter by 1 centimeter cubes. What is the number of centimeters in the length of one edge of the largest solid cube that Julian could build with these cubes? So basically we're trying to find out what is the smallest cube, or what is the largest cube that's smaller than 800, right? So for example, 5 cubed would give you 125, right? And 10 cubed would be 1,000. So our answer, oops, 1,000, I don't know. That's not, looks like 108, but you get the idea, 1,000. We got to find, so the largest cube is going to be somewhere between 5 and 10, I guess, right? So if you know your cubes, then you'll know that 9 cubed is 7, I think it's 729. So that is smaller than 800. But then 10 cubed is 1,000. So you can't make this 10 cubed one, but you can make the 9 cubed one. So the answer is 9. That's the largest one that you can make. That's a solid cube. All right, let's go to the next page here. We've got 3 pages done, and we've got 2 pages to go. Let's see. This says the ratio of girls to boys participating in intramural volleyball at Ashland Middle School is 7 to 4. All right, let's see. Maybe I should use a different color here. Is that going to show up okay? Yeah, that should be fine. So 7 to 4. There are 42 girls in the program. What is the total number of participants? Okay, so the number of girls, boys. So the 7 is the girls. So it's 6 times, the 42 number of girls is 6 times this. So that means that there'll be also 6 times 4 for the number of boys. So you have 42 girls, you're going to have 6 times 4 is 24 boys. They want to know the total number of participants, so we just add these together. That would be 66. 66. Okay, 4 seconds pass between the first and the third flash of a strobe light. The rate at which the strobe light flashes is constant. How many seconds will pass between the first and the 12th flash of the same light? Okay, so you can imagine the light flashes the first time, then it flashes the second time, then it flashes the third time. There's some amount of time between these. This is flash 1, flash 2, flash 3. And that time is equal to 4 seconds, right? 4 seconds there. All right, so that means that between 1 and 2 must have been 2 seconds. 2 seconds here and 2 seconds here because it's a constant rate. So it's 2 seconds per interval. And they want to know how many seconds will go between the first one and the 12th one, right? So how many intervals are there between the first one and the 12th one? There will be 11 intervals in between, right? So you just need to take that 2 seconds, multiply by 11, and that gives you 22. All right, 22 seconds. Okay, the next one, we're going to scroll down here. This says the segments below form 26 congruent squares. What is the maximum number of segments, both vertical and horizontal, that a straight line P could intersect if P is not collinear with any of the grid segments? Collinear means like on the same line. So how many segments are there? There's some vertical segments, like this is one vertical segment here. This is another vertical segment here. This is another one here. And another one here. And there's 7 altogether. So if I draw all the vertical segments, they look like this. So maybe we can just separate it into vertical segments and horizontal segments. I think that would be a good way of approaching this problem. So the horizontal segments are going this way, right? There's one there, and there are also 7 of these. So how if we just started out by trying to find a line that intersected all the horizontal segments, for example, right? You could pretty easily do that. You could pick a line that just went straight across like this. Or no, we wanted to intersect all the horizontal ones, so we could go vertical like this. It would intersect all the horizontal segments. If we wanted to intersect all the vertical segments, we could draw a line across like this. Now, if we wanted to intersect as many of each, we might need to make it a diagonal line to try to hit as many of both vertical and horizontal segments. And it turns out that if you are very careful and draw this line exactly across the diagonal like this, you can hit all the vertical segments. So here you see we've hit all the vertical segments. We're just hitting exactly on this corner and exactly on this corner if I drew it right. And exactly on this corner as well, but I didn't draw it quite right. But anyway, we're hitting all the vertical segments and we're also hitting all the horizontal segments. So we had 7 plus 7, so the answer is 14. All right, let's take a look at number. Where did I go here? Did I miss? Oh, you know what? I should have scrolled. Wait, did I do? Oh yeah, I already did that one. Okay, so we're on 22 now. Wait, hold on. Yeah. Okay, so we're on 22 now. It says how many odd whole number factors are factors of 180. So when they ask you how many factors a number has, hopefully you remember how to do that. Basically, you start by taking the prime factorization. So there's going to be a bunch of 2's, right? There's going to be 2 to the third power. That's 8 and 45. It's going to be left over if you divide 180 by 8. Like if you divide it in, oh no, that's not right. It's 2 squared, right? It's 2 squared. Is that right? Yeah, if I divide by 4, that's 2 squared. If I divide by 2 once, I'll get 90. If I divide by 2 again, I'll get 45. So I had that wrong. 2 squared times 45. And 45 can be broken down into a 5 and 2 3's, right? 3 and 3. So those are the prime factors. 2 squared times 5 times 3 times 3. Now, all the factors of 180 are going to be formed by taking different subsets of this prime factorization. So these are the prime factors right here. We've got to take some subset of these to form factors. But if we include any 2's at all, then it's going to be an even number, and we don't want that. So we can kind of ignore the 2's, and we just have 5, 3, and 3. And so basically, it's you've got 3 squared times 5, and you need to find out how many different subsets there are. So you can just take the exponents. The exponent here is a 2, and the exponent here is a 1. Take the exponents, you add 1 to each one. So 2 plus 1 is 3, 1 plus 1 is 2, and you multiply those together, and you get 6. That's going to be the number of subsets of this factorization here. All right, the next one's pretty easy. You just have to make sure you do things in the right order. So it's testing your PEMDAS. You can see there's a multiplication here that needs to be done first, and there's a multiplication here that needs to be done first. And also it's a little tricky. You have to make sure this minus sign goes on this whole thing here. So this is going to be 42, and this is going to be 12. But it's a minus 12 because of this minus sign here. And then what's left? Over here we have 9 minus 8, which is 1. And over here we have 2 minus 1, which is 1. And then we have a 5 sitting here in the middle, so that's 5. So altogether down here we have 7, and up here we have 30. So the answer can be 37. 37, if I did that right. Yep, that looks good. Okay, this one says Adele can mow her entire yard in 3 hours. Her sister Brooke can mow 3/4 of the same yard in 2 hours. Using 2 identical mowers, what part of the yard can they mow in 1 hour working together? So what I like to do here is think about, for each sister, how much can they mow in an hour? So Adele can do the whole yard in 3 hours. That means in 1 hour, she can only do a third, right? So a third for Adele. And what about Brooke? Brooke can do 3/4 of it in 2 hours. So in order to find out how much she does in 1 hour, we have to divide this 3/4 by 2, so that's 3/8. 3/8. So Adele can do a third, and Brooke can do 3/8, and we need to add those together, right? So to find a common denominator, that's going to be 24. So how many 24ths? We've got 8 24ths plus, let's see, this is going to be 9 24ths. So altogether we got 17/24. Okay, one last page to go. Don't quit now. Here we go. It says congruent equilateral triangles are used to tessellate the plane. How many triangles share a common vertex? So if you put triangles together at a vertex, I mean there's 60 degrees here. And so you can fit 6 of them around a point here, around the 360 degrees. You can fit these all around like this. It'll look like this. And so I think the answer that they're looking for here is 6. But I do want to point out that you can tessellate the plane in a different way with triangles. So for example, imagine you think of this band up here of a bunch of triangles, just this one band. So like you could continue sort of putting a zigzag in here, and you could make, you could make a band of these equilateral triangles going along like that. And we could also do the same thing on this band down here, right? By just continuing this zigzag pattern here. And so you would have something, something that looks, sorry about my drawing, that should not be like that. But imagine cutting this band, and you can have another band below, another band below. You could tessellate the whole plane like this, but imagine taking every other row, like this one here, and maybe the one up above here, for example, and shifting them. So then you might not have these line up together. You might have something where the top row looks like this, but then the one below also looks like this, right? So then at a vertex you would actually have 1, 2, 3, and you would have an edge of a triangle. So I don't know. I mean, I'm sure that what they're looking for is this 6, but you can tessellate a plane other ways. So I don't really love this problem. Because here you've got 3 triangles sharing this vertex. Well, it depends on if you count the one that's... I mean, this one has an edge that's on that vertex, but it doesn't have a vertex there. So I think, yeah, they're definitely looking for 6, and that's the answer on the answer key, but I don't really love the way they worded this problem. Okay, 26. While practicing for a running race, Nakimbe averaged 4 miles per hour for the first 4 miles, 3 miles per hour for the next 5 miles, and 2 miles per hour for the last mile. Okay, so lots of numbers there. The question is, what was the total number of minutes that he ran? Okay, so one thing you don't want to do is kind of try to find his average speed, because it's really hard to find the average speed when they give you how fast they were running for a bunch of different sets of distances. You can't just take an average speed. So what you need to do is you need to take each of these 3 sections separately and figure out how many minutes it would take. So if you're going 4 miles per hour for 4 miles, that's going to take 1 hour, right? And so that's 60 minutes. And then if you're going 3 miles per hour for 5 miles, that's going to be more than 60 minutes, right? Because it would take you 60 minutes just to do 3 miles. And then the next 2 miles would take another 2/3 of that. So that would be, so you'd have 60 for those first 3 miles, and then another 2/3 of that, which is 40 for the next 2 miles. So this is the first segment, and then these 2 are the second segment. And then the third segment, you're going 2 miles per hour for a mile. So let's see, 2 miles per hour. So that's going to be 30 minutes, right? So plus 30 minutes, that's the third segment. Because it's going to be, if you're just going 1 mile, that's only half of the 2 miles. So it'll take you half an hour. So the total number of minutes, you just add these up. This is 190, right? 190. Okay, a bag contains 16 congruent blocks, 4 of which are blue, and 12 of which are red. 2 blocks are randomly pulled from the bag at the same time. What is the probability that both blocks are blue? Express your answer as a common fraction. So even though it says they're both pulled from the bag at the same time, it's easier to explain this problem if you think about taking them one at a time. And it turns out the probability is still the same, because you're not replacing one, and you're not taking one out and then putting it back in and then taking another one. So let's say you took the first one out. What's the probability that that one's going to be blue? Because if they're both blue, the first one's going to have to be blue. And so that's just going to be 4 over 16, because there's 4 blue out of 16, which is equal to 1/4. So that's the probability of the first one. And then once the first one's out of there, there's only 15 left. 15 left, and 3 of them are blue. So the probability that the second one is going to be blue, assuming the first one was, is going to be 3 out of 15. So we need to multiply these two probabilities together, because you have to have both of those happen. So you have to multiply the two. So 1/4 chance that you're going to get the first one, and then even if that happens, you still have to get the second one, which is going to be 3/15 chance. So it's 3/15 of 1/4. So of means you're multiplying. All right, so this is going to be 3 over, well, actually, we can simplify this to 1/5, right? This is 1/5. So it's a fourth times a fifth, and it's going to be 1/20th. All right, what is the greatest prime factor of the sum of the arithmetic sequence? 1 plus 2 plus 3, all the way up to 80. So this is going to be quicker if you know the trick for adding these sequences, basically where you take the first one and the last one, and you add those up, and then you take the second one and the second to last one and add those up, and you just pair them up like that until you get all of them paired up. And so this is going to be 81 for each of the pairs. So we've got 81 is the sum for each of the pairs, and then you have to multiply by the number of pairs. Well, the number of pairs is going to be half the total number of numbers. The total number of numbers is 80, so half of that is 40. You multiply 81 by 40. Well, actually, we don't even have to do the multiplication. They just want to know what the greatest prime factor of this thing is. We can take the prime factorization right from here. So this one, all the prime factors of this is going to be 3. And for this one, we're going to have some 2's, and we're also going to have a 5, right? So we're going to have like 2 cubed times 5. So the greatest prime factor is the 5 here. So let's put that in 5. Okay, we are moving right along. We've only got 2 more problems to go. So we're doing great. Okay, so a number x is twice its reciprocal. Okay, so x is equal to twice its reciprocal. This is how you write this. Okay, so x is equal to 2 times its reciprocal. This is the reciprocal of x is 1 over x. So this is also equal to just 2 over x, right? So x is equal to 2 over x. They want to know what is x to the 6th. Okay, so let's forget this middle part here. Let's just multiply both sides by x. So that gives us x squared is equal to 2. And this is one of those problems where you don't really have to solve for x, even though x is pretty simple to solve for. It's square root of 2. But once we know x squared, we can find x to the 6th by just taking that to the third power. So if you take the third power on both sides, you get x to the 6th is equal to 8. So the answer is 8. All right, this is the last one, the hardest one. It says, what is the minimum number of United States coins Samantha needs, pennies, nickels, dimes, quarters, half dollars, to ensure she is capable of making change for any amount of money from 1 cent to 99 cents? Now this is going to get pretty tricky. But the trick that I found that helped me with this problem was to start by thinking about how many pennies am I going to need? What's the minimum number of pennies that I'm going to need? So for pennies, just start thinking about making different numbers. Like if you got to be able to make 1 cent, so you definitely need 1 penny. 2 cents, 3 cents, 4 cents. There's no way you can use nickels or dimes or quarters or half dollars to make any of those from 1 to 4. So you're going to need 4 pennies for sure, right? You're going to need at least 4 pennies. Who knows? Maybe we need more, but we need at least 4 pennies. And then I started to think, well, how many nickels do we need? What's the minimum number of nickels we need? And I thought, well, if we only want 4 pennies, we're definitely going to need at least 1 nickel. I shouldn't have circled it probably. Let me make it consistent with this one over here. So for pennies, I know I'm going to need at least 4. For nickels, I know I'm going to need at least 1. Once I start making 5, 6, 7, 8, 9, I'm going to need a nickel. Okay, so now with these 2 sets, the 4 pennies and the nickel, I can make the second digit of any of these amounts of money, right? From 1 up to 99. So everything else I can do with dimes and quarters and half dollars, I guess. So what's the minimum number of dimes I'm going to need? And I started thinking, well, if I make, for example, 24 cents, I could do that with a bunch of nickels, but it would be more efficient to do it with dimes. So I'm probably going to need 2 dimes. Because if I use less than 2 dimes, let's say I only have 1 dime, when I make 24 cents, for example, I'm going to need a bunch of nickels. So yeah, so I'm going to put 2 dimes, and all these are kind of subject to change. I could change my mind about these, but I know I need at least 4 pennies, at least 1 nickel, at least 2 dimes. And I think for quarters, it's a good question. Do I need 1 or 2 quarters? That's probably the hardest part of this problem. I'm going to start with 1 and see how we go, and then if we need to, I'll come back and add another quarter. So let's start thinking about all the amounts of money. So I can get up to 4 cents just with pennies. With my nickel, I can get all the way up to 9. I've got a dime, so I can do 10. And then I said I can do all the way up to all the ones digits I can take care of. So if I can get up to 10, I can definitely get up to 19 by adding in these. So, well, is that true? Because I do have to use my nickel. Oh yeah, no, that's fine. I can get up to 19 just because this dime is separate from these. And then I can get 20 from the 2 dimes, and then I can do all the way up to 29 with the pennies and nickels. So I'm up to 29. And then 30, let's see. So 30, I can use a quarter and a nickel. And I can get up to 34 with these pennies. But when I do 35, I guess 35 is a quarter and a dime. So that's fine. And then I can use pennies to get up to 39. And 40 is easy. I just do a quarter and a dime and a nickel. So I've gotten up to 40. Um, 40, and I can get up to 44 with these pennies. Now 45 is just this quarter and these 2 dimes. So I can get up to 45 and then up to 49 with these pennies. So I can get all the way up to 49 for sure. And I was trying to think if I needed 1 more quarter. But I got up to 49 with just these coins here. And now I can just add $1/2. And if I just add that $1/2, if I know I can get anything from 1 to 49, I can get anything from 1 to 49 with just these coins over here. Then if I add in $1/2, that'll do everything like this plus 50 cents. Right? So that'll take me from 51 up to 99. And 50 is also possible with this $1/2 just by itself. So with these coins, I can do any amount of money from 1 cent up to 99 cents. So how many coins do we have? 4, 5, 6, 7, 8, 9. So the answer is 9. Hope you guys enjoyed that video. This should give you a flavor for what the school sprint competition will be like. There will also be a target round. You'll get 1 point for each of the 30 sprint problems that you get correct. And you'll get 2 points for each of the 8 target problems that you get correct. In the target round, the problems are a little bit harder usually, but you also get a calculator. So yeah. So good luck, everyone, and we'll see you guys on Monday. All right. Have a good one.